Computational Risk-Averse Optimization in Finance, created by Rha Overstreet and Jesus Dominguez Castaneda. Faculty Advisor, Dr. Akwam Anwunta, a special recognition to the Outreach ISD program headed by Dr. Alexandrescu. Financial markets have proven to be less reliable than previously thought. With the multitude of pandemics, market crashes, global recessions, and wars occurring in the past couple of decades, it can be observed the financial markets are a risky place for asset allocation. Outside of entrepreneurship, investing in markets is the only way to grow assets. Within the umbrella of markets available to us today, the lowest barrier to entry is the stock market, allowing everyday people to participate either through high-yield saving accounts, hiring wealth managers, or becoming a retail investor. The first option does not compete with inflation, so in effect the value of your asset is diminishing. The second option requires a large amount of capital to afford the fees and options presented to you. The third option is becoming a successful retail investor, which takes years of practice to become profitable. Our aim is to assist risk-averse retail investors with the plug-and-play method of investing. Computational Risk-Averse Optimization, or CVAR for short, uses the expected asset returns found in the tail end of the probability distribution. These are extreme, improbable losses that occur during stock market instability. Currently, we are building on this technique using machine learning methods. In our research, we use a portfolio comprised of stocks distributed across multiple industries. Portfolio optimization is the process of choosing a group of assets by a method of choice and allocating your money optimally across those assets. The asset allocation is determined by the investor's objectives. Objectives can range from maximizing portfolio returns, minimizing portfolio losses, only allocating a certain amount to specific industries, only investing in ESG companies, and etc. For this research, we minimize portfolio losses using the CVAR method. The CVAR method is the expected loss of an asset if the worst case scenario occurs. The worst case scenario is determined by the investor's risk level, also known as the alpha quantile of the distribution, or the value at risk, also known as the VAR. The CVAR model is bounded by the VAR alpha, which is how much you are willing to lose, and the CVAR delta, the threshold of expected losses. This means that any asset with an expected loss beyond the CVAR would either have a weight of 0 or a very small weight in the overall portfolio. In order to create an optimized stock portfolio based on the CVAR method, we applied the above constraints to a linear optimization model. For our research, we chose to use an alpha of 0.2 and a delta of 0.025. We used the adjusted closing price of each asset from January 19th, 2012 to January 20th, 2022. These are the 10 assets and the weights and percentage they were given in the portfolio. Apple Corporation, 0.6%. Cisco Systems, 27.9%. Microsoft, 0%. Comcast, 22.7%. Target, 17.8%. Monster Energy, 5.7%. Pfizer Pharmaceuticals, 20.8%. Starbucks, 0.3%, Fiserv, 0%, and Marriott, 4.2%. During the holding period from January 20th, 2022 to March 3rd, 2023, our optimized portfolio lost 294 basis points. The S&P 500 lost 974 basis points. We're currently working on using long short-term memory recurrent neural networks to predict asset prices to aid in our portfolio optimization. Long short-term memory, or LSTM for short, is a type of machine learning tool suited for time series predictions. Conceptually, it is a peephole that allows a system to look at the previous states of the system and use the important information from those previous states to improve the system. This allows the LSTM to incorporate long-term dependencies into its predictions. In an LSTM node, there are 3 gates that determine the node/cell state. The first gate that information passes through is the forget gate. Basically, do we keep these dependencies and biases and introduce it to the cell state? After being processed in the forget gate, the information is passed to the input gate. Once in the input gate, the data is passed through 2 functions. The first is the activation function, which gives it a value of 0 or 1. The second is the function that assigns weights based on its level of importance from -1 to 1. The output gate then goes through the process one more time before filtering the data to the next node. A basic implementation of LSTM can be observed with this example of Apple stock being predicted 18 days in advance, where the actual price is 165.02 cents and the predicted price is 168.26 cents. In conclusion, We're striving to create a system that'll allow us to create CVAR optimized portfolios for different holding periods using LSTMs to predict asset price. We believe this research could help the everyday person navigate the tumultuous nature of the stock market.